There we are. It's me, John Park, and we're here in John Park's workshop. Thanks for stopping by. Wow, have we got cool stuff to talk about today. I have gotten some excitement going over 2D side-scrolling platformer games, I must tell you. And so we're going to take a look at a whole bunch of different stuff to understand how 2D side-scrolling platformer games work, as well as how to make your own inside of MakeCode Arcade, and even get some of those games onto hardware, such as our little Pi badge here. And here's another one. Let's see if I can get it up there. And here's a little top-down overhead car driving game. So very excited to share all that with you. But first, let's mention a couple of little housekeeping-y things, such as, did you know we have a jobs board? That's right. That is jobs.adafruit.com. And let's pull that up in the browser here. How about have a look at some of the jobs that are posting. So this is an entirely free jobs board, and you can post your resume there if you're looking for work, and you can also post jobs if you're a company looking for an employee or for some contract work to get done. So you can have a look here and see some of the types of things that are showing up. Here's a new one: CTE and Makerspace teacher at Capital City Public Charter School in Washington, D.C. is looking for somebody full-time. That's fantastic. So go check it out. You might find something that suits you. Huh? Check it out, really. It's free. And let's see, what else have we got to talk about here today? Let me pull my chat over there. There we go. Oh, you know what? I have a little something here. It's the coupon code. So this is this week's coupon code for the show, or today's coupon code for the show, and it is scrolling. Scrolling will get you 10% off in the store, so head to Adafruit and find some cool stuff. When you find that cool stuff, put it in your cart. And then when you're ready to check out, this will get you 10% off, unless it's software or gift certificates or subscriptions, such as the AdaBox. That won't work. But 10% off on all the physical goods. So speaking of which, I've got actually a little product of the week that I'd like to mention. And this is this really cool USB to 2.1 millimeter DC jack cable. So I've got one over here, and I'll show you what I got it hooked up to and why it matters in a second. But first, there's a look at it. So this is a standard USB cable on one end. I got so much stuff to take care of. Here we go. And then in the middle, we've got a little boost converter that takes the 5 volts and boosts that to 12 volts. And then on the end here, we have, let me get that out of the, we have the little sort of typical barrel plug, 2.1 millimeter barrel plug that you'll find on a lot of 12 volt things. So here's an example of a 12 volt thing. I've got one of our new little side light fiber optic tubes with a light source. And this light source, oh, let me screw this in tighter. This light source is 12 volt. So to run that, what I've done is I've connected to one of our little screw terminal to 2.1 millimeter jacks here. And then when I plug in our cable, I can now run that off of USB. So I'm going to plug it into a, gosh, I keep getting the camera wrong, sorry, a little battery boost that I made. So there's a LiPo battery there. And now I can turn this on. I get this cool fiber optic glow, as well as the very pointed light at the end there. But this is the type of fiber optic that's sort of optimized for this side illumination. So the light beams bounce around in there, but rather than running clean straight to the end, they actually give off a decent amount of light to the sides. So that is a pretty cool little product. I'd actually never used it before, but I decided, hey, it could be fun, let me set this over here, to find a good way to light up those little 12 volt. And you can check the specs. I think it'll do something like 300 milliamps, 400 milliamps, which is well within the range of USB. And I think that is maybe a 200 milliamp or 100 milliamp LED there. So that's perfectly fine and within specification. So go check it out. Here it is in the browser. Let me pop back over there. And you can see it for itself. There it is. The 2.1 millimeter 12 volt. I think we also have a 9 volt cable. Let's see, I think if we scroll down. Yeah, so there's one here that'll give you 9 volts. And then we have another that'll just go the straight 5 volts out. So it's just, it doesn't have the booster in the middle, but it's a way to get a 5 volt to a DC plug. So that is my little product of the week, this very cool booster cable. Very useful thing to have around. All right, so that now brings us over to this thing. That's right, it's the Make Code Minute. And in Make Code Arcade, I want to talk about creating a tile for a tile-mapped level. So the first thing I'll do is have a look at the simulator here. And what you can see is I have this little top-down car driving game. And in here, the intersection is only headed one way across. And I'd like to turn that into a four-way intersection. So what we can do is have a look at how these tiles are created. Right now I have this thing that is the tile map. And what this does is it lays out where different tiles, little sprite tiles, are placed on the map. So you'll notice there's a bunch of horizontal lines here made of red. And if I look at the tile maps, here's this red one. That is this horizontal piece of road. So what I'm going to do is I'll just duplicate any of these. Let's duplicate that one. And actually, I don't need those. I can set those off to the side. And this new one, what I'm going to do is say this is, how about light blue? Or maybe let's make it pink. Be able to see that one. And let me just make sure that that's in camera view. And get that up there. There it is. Okay. So in camera view right now, I have this pink tile. And what I'll do is I'll add that to the tile map by picking the pink brush and laying down 1 pixel. So the intersection now is going to display whatever sprite image appears in the pink index. So looking at this new pink road, it's the same. It's this horizontal. But if I want to make this sort of a four-way intersection, what I can do is just grab a nice big brush. I'll get rid of some of this and some of this. And we'll call that done. So now what it's going to do is going to replace any part in that tile map where I place pink with that four-way intersection. So now if I make my map large, oh, I can see the green is see-through thanks to my green screening. Can I get this a little higher up in the screen? I don't think I can. Let's just cheat that up a little bit. I'm going to poke through. So now you can see in that tile map where I placed the 1 pink pixel, we get our little four-way intersection. Now that actually isn't currently changing how it worked. It's always going to let me drive there because I have it as walls turned off style. But now the graphic kind of matches what it actually does in the game. And so that is how you can change the sprite for a specific part of your tile map in Make Code Arcade. All right, well, I hope that was clear, but the good news, if it wasn't, that's okay, because we're going to dive a lot deeper into tile maps in games today. So for the project of the week, what we're going to be working on is a platformer game with side-scrolling graphics. So a platformer is essentially a game where you're jumping on platforms, walking, running, jumping, climbing on platforms to get usually from one side to the other. And side-scrolling means that the action isn't limited to a single screen, but rather it takes place in a sort of long horizontal screen that moves sideways. Sometimes the screen will also go up or down, sometimes left and right, sometimes only to the right. But the notion of having a game map that's larger than just the screen that you see is kind of one of the fundamental things that we're going to talk about. And I have a few ways that I'd like to demonstrate that. Let's head over to the workbench, and I want to show you this little demo I made of a side-scrolling game, and it's actually the one we're gonna make. But this version is made with paper, and so I've got a little rig here. I'll show you the rig in a second, actually, too, because I think that's kind of interesting. Let me give myself some space here, get some things out of the way. So what you're going to see here is I'm going to move my camera sideways, and as I do so, we'll kind of ignore the fact that my character is kind of going through walls. As I move sideways, we can see I am progressing through the level with my little character here. We can fall down into the pit, and we can make it to the end. So I'm going a little crooked here. Let's go back. And depending on how quickly we move our character, that's how quickly we're also going to move our camera. And you'll notice one of the really nice effects we get, and this is actually a semi-advanced technique from the perspective of video games, is that we have motion parallax. And what motion parallax is that we have distinctive planes of, let's say, a foreground, a midground, and a background. And by moving them at different rates, we give the illusion of depth. And so, as you can see, the foreground of all these pink blocks and that coin block up there above my character's head, all of those things are moving at a quick rate, and our background is actually so far away that it, in essence, isn't moving at all. And so let me switch to this overhead camera just so you can see how this is built, just because I think this is kind of interesting. So what I have here is, let's go to that view there. So what I have here is some layers of the game map that I've created on different pieces of Mylar. And then I have my character. You can see that, I think. Let's zoom in a little more. I have my character. I'm going to move my camera out of the way. You can see there the character and background are moving. That does not want to focus, sorry. While my level is staying put. So if I bring this camera back into the frame here, you can see that by sliding the character and the background but leaving the game level alone, I'll hide that. Again, that's a little in the way. We get that effect of the parallax. So there you can see I've just got a piece of wood and I taped that moving background. There you go. You can see it better there. So I built a level. I just printed it on a color printer and cut it out, and then sort of spray adhesive stuck it to some Mylar so it would stay put. So I've got that stuck down to the workbench, and it's very similar to this. This is actually going to come into play in a second as we talk about how these game levels are designed. And then my character's on a foreground layer of plastic, and my background is back there. And the net effect of that is that if we move our character and our background at the same rate, and we leave our come back here, and we leave our level itself staying put, you get, that's a little close up, you get the effect of traveling through space in a fixed map. So let's have a look at these layers here, because this is actually, I think, important for understanding how a game level works. I'm gonna ruin that part of the demo, I think, and peel this off of here. So that served its purpose. And let's try to zoom in enough to see what's going on. There you go. So this is the game level artwork. So you could consider these a bunch of sprites. Just wherever you see a little block, that's a sprite. Some of them are a little larger. Most of them are 16 by 16 pixel sprites in the game space. And then here I have these two layers of my character art, which is my little Ruby sprite, and my background. So by setting this back here, what's happening essentially in the camera space is that you feel like the let me peel this off. You feel like the level is moving, or ideally you feel like the character is moving through the space like this. And by mapping one background to always stick essentially with our character, there's a little bit of leeway in the game, it feels like that is much further back there. Now, I said that this wasn't always the case. In fact, if you look at pretty much all the games on the first Nintendo Entertainment System, the NES, did not have parallax scrolling or multi-plane like this. There just wasn't the memory to do it. So everything, you'll see that the background moves at the same rate. So clouds and mountains and things like that are all moving along with the character as the scene goes scrolling by. Another way to look at it is, if I can get it to focus on that, is we can move the level, right, since this camera is fixed now, and that's the net effect of what we see. So I mentioned that these levels are made up of this sprite artwork, so these individual graphical elements, such as these pink blocks here, and underlying them is the level design without worrying about the artwork. So if you look at this, essentially is a tile map. So remember previously when I placed down that pink block to say that's where my little intersection is going to go, this is how we tell the game to repeat something over and over again. So if we look at these pink blocks here, those correspond to, I just kind of arbitrarily chose this purple color index. So wherever I place down the purple color is where that piece of artwork goes. And the reason for doing this originally is that we didn't have a lot of memory. So in order to fit what seemed like a large game world into the limited memory of a video game system, you needed to use tricks like repeating a very limited set of artwork all over the place, because it doesn't take extra memory to show something on screen in a lot of different places. Nowhere near as much memory as having one large graphic or having unique graphics. So you'll find that a lot of game levels are made up of something like this. So here I've created essentially a mapping for what we see in our level. So like I said, wherever I drew purple, my pink blocks show up. Wherever I draw yellow, I get the little coin box. This teal, I get a sort of ground block. This blue, I get a ground block that's got grass on the top of it. Light blue is a pole at the end. Red is this sort of dangerous lava pit. And green is where I'm going to put this pipe. So let's have a look. I'm going to move back over to the computer, and we're going to look at this stuff inside of Make Code a little more specifically. But I hope that gives an idea of what the effect is and how this is created. So let's jump back into Make Code, and I'm going to switch to another scene, and I'm going to turn off the green screen. Let's see what that looks like. All right. I think we're going to pretty much full screen it here. Give me 1 second to adjust these settings. All right, so in Make Code Arcade, what I'll do is I can turn on this simulator, or I can stop it just to conserve memory and stop it updating all the time, run a little faster. So I've stopped the game from playing. And now if we take a look at the tile map here, you can see that's that same strip that I had printed out, where we have a very limited little simple world view. And it's actually only 32 pixels wide by 8 pixels high. Remember, my coin boxes are the yellow dots. So what I'm going to do right now is just add a bunch more of those coin boxes, and you'll see what that does to the level. So I hit done, and when I hit play over here in the simulator, and I'll make that full screen so you can see that better, now I've got these coin boxes all over the place, and I have them set to add to my score and produce this little confetti effect when I hit them. I don't think I can jump high enough to get onto that one. The game mechanics I have in here right now are really simple. It doesn't do a heck of a lot. It does play back our animations that we built last week, and shows the different directions we're going, but that's about it. So you can see there that it's very easy for me to create and change my level design by going in and editing the tile map. And the other interesting thing is if we want to change the artwork, since this tile map isn't one giant map of all the artwork and all of the sort of gameplay level design, and instead is just referencing those images that we have stored in the individual tile blocks. When I look at this one, for example, where yellow is my coin block, if I want to make a change to that artwork, I can make it just in one place, and then it's going to be globally updated everywhere. So how about we change these tile blocks to be orange with green for the question mark. And when I hit done now, it's going to update. And now if I expand and play, you'll see I've now updated the game artwork sort of universally by only adjusting it in one place, which is a really nice way to keep consistency in the game. We're not having to go and make changes everywhere and maybe forget about them. Instead, we're in essence instancing or referencing that one graphic in a bunch of different places. Something else that I did just to make it a little easier to conceptualize is I added one button that turns the tile map index into the graphics. So if we hold down this, we're now kind of running around inside of that tile map version of the world, and if I release that button, we go back to the graphics. I'm also hiding the background. And I think this is a nice way to look at how simple the design is of the level without the complication of the graphics. Now you'll also note that I'm not able to go through these things, and the way that's achieved is also with the tile map. So this is sort of a third function that it has. And you'll notice in my tiles, they all have this with wall turned on button. So if I take, for example, the pink blocks and turn off that with wall on switch, now I'll be able to walk right through them. And you'll notice that I'm going in front of them. Oh, that pipe I'm going to bump into, though, because it has wall turn on. You'll notice that I'm walking in front of them, and that's because the game defaults to having the drawing order be the characters at the sort of front of this stack, if you think of the layers of the game. So in the far background, we have the background. In the midground, we have our level, and then in the foreground, we have our character. Now, if you get multiple characters, for example, one's going to have to go in front of the other. You can actually set, we'll maybe look at this in another time, but you can set the drawing order to put something further towards the front or further towards the back so that you can get the overlap that you want. So now let's have a look. I hope that demystifies to some degree what's going on in the game. You can see here I've got it running on the Pi badge. Oh, let me hide that workshop view. What's that doing there? You can see I've got it running on my little Pi badge, and if I hold down the B button, that's where I'm switching. So I get the camera to focus on that a little better. Switching the graphics on and off, essentially. And but the game still functions. Now, the other one other thing about tile maps that I want to mention, there's actually yet another function they serve. They're really, really useful. Another function they serve is additional gameplay mechanics. So if I'm going to zoom in and have a look at this red one. So let me see if this is on screen for you. Yeah, so you can see in my tile map definition, I have set red tile to be this sort of fiery lava graphic. And it would be fun to maybe do animation, make it a sprite that's animating. But here I've just got a simple, or add an effect, but here I've got a simple red lava-y looking thing. And you'll notice it has an alpha channel, so wherever we haven't put down any pixels, it's just going to show through the layer behind it, or our background image. And you'll see in my tile map, I've placed these two blocks here. So I've got two of these lava blocks next to each other in this little pit. Now, in my code here, I've got this little event called on sprite of kind player hits wall, and then I can pick any one of my 16 index colors. So what I'm saying is if my character hits a red block, then I'm going to run this game over animation. So you can see this in practice now. Let's run on over there. Oh, it's easier to run over there because I don't have to jump as many things. And now I'm going to switch over to the graphic here for a second so you can see there's my little red pit. And when I fall into that, my character has just touched the block that's got that red index back there, and therefore we get the game over event to run. So you can see this is a kind of a canned event that does a whole lot for you. We could switch that out to be other things like a camera shake and an effect instead of the game being over, as simply as running over here to, I think in our scene, I can grab a camera shake, and let's try that. Let's make it big. Let's make a 8-pixel camera shake when we hit the ground there, but it's not going to cause the game to end. You can also do things like change the speed of the character, which would be nice in this instance. And now you can see whenever I'm touching that, it's just shaking. We could be losing points, we could be losing lives, or changing some variable value. But you can see actually the level is shaking so much that we're seeing underneath it. You can see the mountains back there behind the background. Whew! And we stop shaking. So that is another use for that tile map. So you can see there's a whole lot that you can get done just with that one little simple 32 by 8 pixel map. One other thing I want to do is sort of peripheral to this. For some reason we had sold our copy of Mario Maker. So there's a game called Super Mario Maker that was out for the Wii U about 4 years ago, I think it came out. There's a new version coming out in June, I think, for the Switch. But this game is essentially both a game that you can play Mario-style game levels in, but you can also build levels. That's why it's called Mario Maker. So what I'm going to do is I'm going to switch over to this camera and head over to the workbench. And I'm going to plug in a Wii U that I've got prepped over here to the HDMI output. Let's steal this, and we'll see if the camera swaps over. Okay, so there you can see the kind of main reason I wanted to show this is that it's a rarity to get to see a game level without playing it sliding by. So you can see I can just easily fly around this level, and then you can use the controls to lay down bricks, very similar to what we're doing actually. So I can just draw in some bricks there, which is really fun because we're doing both essentially the tile map and the artwork at the same time. So it's very intuitive. But this is really a nice illustration of how the game level map works. And you also notice I mentioned that there wasn't parallax in these earlier versions. So this is sort of true to that. The background moves at the same rate as the foreground. In later games, I think on Super Nintendo, they started to add parallax, where you had the background moving at one speed and the midground moving at another, which is a pretty cool effect. So that is Super Mario Maker. I encourage you to check it out because it's a heck of a lot of fun. You can also get it pretty cheap used if you happen to have a Wii U. Go check it out. Otherwise, definitely take a look at MakeCode Arcade because it's free. It runs in your browser. Just go to Chrome browser. That's the one that it runs best in. I think it's also being worked on in Edge a lot now, one of the Microsoft browsers. But check it out. It's MakeCode Arcade is what you'll want to Google. I forget the URL, arcade.makecode.com probably. And right in there, you'll be able to start building these platforms. There's also examples that you can check out. Just open up any of the example platformers if you want to follow along. And I'm putting together a Learn Guide that'll be out soon that will guide you through this process of building your level as well as your sprite artwork for the level and some simple character mechanics so that you can have a little bit of gameplay too to check out. So with that, that is today's episode of John Park's Workshop. I hope you enjoyed it. Thank you, Mr. Certainly, in the chat for pointing out that I am doing a great job because I'm playing games at work and getting paid for it. Yeah, it's lots of fun. In fact, my wife asked yesterday, are you working or are you playing right now? I said, this is for work. I was playing around with Mario Maker, trying to unlock different aspects of it so I could see all of the tile blocks. But yeah, work and play kind of collide into one at this point, which is how I like it. And with that, I will say goodbye. Thanks, everyone, for stopping by, and I will see you next time. Oh, I almost forgot. Before I go, scrolling is your coupon code. So go to the Adafruit store, 10% off. You could get that cool cable, that 12-volt USB cable, very cool, or all kinds of other stuff, and sign up to get notified when the Pi Badge is available, or the Pi Badge LC, which is the light version that is $10 cheaper, and it just removes a sensor and some of the LEDs and some of the connectors. So go put those on your list. All right, that is all I got for today. Thank you.